Hi, in this video we will see how to simplify the radical expressions. So here we got three problems. Two of them has numbers inside the radical and the third one has variables inside the radical. So let's do the first one, which is part A, that is square root of 32. And regarding the basics of this radical, we know that this is a radical symbol. This 32, we say it as a radicand, and the index. So here the index is not shown. Usually it will be written as 2 or 3. So since it is not written here, it is understood that the index here is 2, which means the radical is otherwise called as square root of some number. So let's see how to do this one or simplify the square root of 32. And whenever we want to simplify a radical with square roots, we need to be writing the number inside as a product of two numbers where one of them or either of them is a perfect square number. Let's see how this works. For example, consider a radical with a, and this a is a number which can be written as a product of two numbers, that is b into c. And in this case, either b can be a perfect square number or c can be a perfect square number, or both can be perfect square number. Let's see some examples to understand this. For example, consider a radical that is square root of 18. And this 18, I can write it as 9 times 2. So therefore, this becomes the square root of 9 times 2. Now, according to the rules of radicals, we can write this as product of two radicals, that is square root 9 times square root 2. And so we can simplify this further. We know that the square root of 9 is 3, and this square root of 2 we cannot further simplify, so we write it as it is. So we are getting 3 root 2, which is the simple form of square root of 18. Let's see one more example, that is if we have to simplify square root of 81, I can write this as a product of 9 times 9. And now I see that I can apply the product rule, which says it can be written as square root 9 times square root 9. And we know that once again the square root of 9 is 3. So this becomes 3 times 3. And so the answer is 9. So see that the square root of 81 is 9. That is a simple form of this radical. So the point here I wanted to let you know is that in this case, that is in the first case, only the 9 is a perfect square number and not the 2. But here in the second example, we saw that the 9, both numbers are perfect square numbers. So we will have two possibilities like this. Now let's work on our problem, that is square root of 32. So there are several ways that this can be written as a product of two numbers. I can write this as 4 times 8, or I can write this as 1 times 32 also, in fact, or I can write this as 16 times 2, and also I can reverse the order, it doesn't matter. Suppose if I have written in this form, now let's simplify this. This can be written as root 4 times root 8, and so this becomes root 4. I know that it is 2, and root 8 looks like we can further simplify. That is, I can write that as 4 times 2, and so this becomes 2 times of this square root of 4 is 2, and so this is 2 times 2 times 2, and this gives I'm sorry, the last one is not just 2, it is square root of 2. So therefore we can now see that 2 times 2 is 4, and this becomes 4 root 2. So this is the simple form of the square root of 32 if you are doing this way. Now let's see the other forms. The square root of 1 times 32 is not different from square root of 32. So we can simply cancel this. We will not follow this, which means we can look at the other one. So here we have written this as square root of 16 times 2. And so therefore this can be written as product of two radicals, that is square root 16 times square root 2. And so this becomes, we know that square root 16 is 4, and then the square root 2, we write it as it is. So in both ways, we are getting the same answer, that is 4 times root 2. So it doesn't matter how do you split the number, the big number inside the radical, as a product of two numbers. One of them can be a perfect square number, or the other can be a perfect square number. The both can be perfect square number. So however the way that you work it out, finally it should lead to the correct answer. Let's do part B. So here we have to simplify the radical expression root 2 plus 3 root 2 plus 4 root 2. Looking at this radical expression, we see that root 2 appears in all the terms. So it's more like doing like algebra. For example, if we have to simplify an algebraic expression like x plus 3x plus 5x, we say that this is equal to, this is 1x plus 3x, which is 4x, and then this 4x plus 5x, and that is equal to 9x. So we do similar to this. So I can now say that this is equal to 1 root 2 plus 3 root 2, and that equals 4 root 2. And then I add this with the another 4 root 2, and then this becomes 8 root 2. So this simplifies to 8 root 2. In part C, we have to simplify a radical expression with a number and two variables inside, and also the variables are in power or exponent form. And so here we have the radical with index 4, which we usually called as fourth root of the numbers whatever inside. So let's see how to simplify this. In the first step, we are going to break this down as a product of three radicals using the product rule of radicals. That is, I can write this as the fourth root of the number 16 times the fourth root of x to the power of 8 times the fourth root of y to the power of 5. So this is the first step that we do. We split this into product of three radicals. And in the next step, we need to write each of the numbers inside the radical, that is the radicand, as a power of 4. Because we are working out with root 4, so we need to write the 16, x to the power 8, the y to the power 5 in terms of power of 4. And so we know that 16 is equivalent to 2 times 2 times 2 times 2. And so in exponent or power form, this is equivalent to 2 to the power of 4. So we can write that here. This becomes 2 to the power 4. And also we write this in exponent form, that is the root 4 can be written as to the power of 1/4. And likewise x to the power of 8, I can write this as x to the 2 power of 2, and once again to the power of 4. And finally for the radical, that is root 4, I can write this as 1/4. And then I have this y to the power of 5. So we can write this as product of y to the power of 4 times y to the power of 1. And then this is to the power of 1/4. And this is for the root 4. So this is the second step. And in the third step, we apply the rule of exponents. That is, we know that these two exponents gets multiplied. all these exponents gets multiplied. We will see for the last one. Let's do the first two. And so therefore this becomes this 4 times 1 by 4. This will become 1. So this actually becomes 2 to the power of 1. And then here this once again this 4 times 1 by 4, that will become 1. So here we have x squared to the power of 1. And this one we are going to apply the rule of exponents. That is, if we have a times b raised to the power of m, we can write this as a to the power of m times b to the power of m. So basically we applied this rule first. So therefore this becomes y to the power of 4 and then raised to the power of the final root, which is 1/4, and then this multiplied with y to the power of 1 and raised to the power of 1 by 4. Now let's simplify this further. So this is equal to 2 to the power of 1 is 2, x squared to the power of 1 is x squared. And then here you see that once again we can multiply these two powers. This 1/4 times 1 by 4, that is equal to 1. So then it becomes y to the power of 1. And finally this one, if we multiply, it's once again going to be y to the power of 1 by 4. So we can write it as it is. Let's further simplify. So therefore we can now multiply each of them. So this will become 2x squared y power 1 is y. And then y to the power of 1/4. We can write this back into the radical form. So this becomes y, and in radical form 4th root of y. And so therefore this is the final answer to this question.